Last day for permutation and combination. So, hey, we made it through. All right, so this lovely little table is just a nice summary of the different things that we've talked about in this section in this chapter, from the fundamental counting principle, and then you've got your different types of permutations. So reference it when you need to. Really is what I was trying to say. Sorry. All right. So example 6: a student advisory board consists of 17 members. 3 members will be chosen to serve as the board's chair, secretary, and webmaster. Each member is equally likely to serve in any of the positions. What is the probability? So what we're doing is we're taking permutations and combinations today, and we're working them into the probability portion of our chapter. So what is the probability of randomly selecting the 3 members who will be chosen for the board? So here's the thing about this. Because it's a chair, a secretary, and a webmaster, order is going to matter. So if order matters, right? If order matters, that means it's a permutation, right? Permutation. So we have to figure out the number of ways for this to actually happen, of ways for this to, for us to choose. Okay. We're going to use NPR, right? So math probability number 3, I think. I don't remember which number it is. You just have to look at it. Watch the other videos or look at the other PDF. They'll tell you. So we have 17 members on the advisory board, and we want to choose 3 of them where the order does actually matter. Well, then to make it into a probability problem, right? All we're going to do is basically, what is the probability of randomly selecting the 3 members? Well, when you select the 3 members, you're really just making one choice. So that probability is going to be one way to do it out of the however many ways that is. And so it's really going to be 1 out of 4,080, which is 0.0002. Okay, and guys, please do me a favor. I know I've said this in other videos, but please, please, please read the directions in my math lab. It tells you if it wants it in a fraction form or a decimal form, and it also tells you where to round. Please pay attention. You should not be missing that just because you're not reading the little sentence underneath where your answer box is. Okay? All right. Student advisory board consists of 20 members now. 2 members will be chosen to serve as the board's chair and secretary. And again, because we have a chair and a secretary, not just, hey, it's a 2-member group. The order is going to matter. So when we do this, and the fact that we're making this into a probability problem, right, there's going to be one of those choices out of 20p2, right? So it's 1 out of 380, and I don't think I did. So that is 0.003% probability, okay? All right, find the probability of being dealt 5 diamonds from a standard deck of playing cards, okay? So find the probability. Order is not going to matter, okay? Order doesn't matter. Order does not matter because we just want 5 diamonds. It's not saying, oh, we want the ace first and then the king and then the 3 and then we don't care about that. We just want 5 diamonds. So our probability for this is going to be the number of ways to choose, sorry, I can't spell, 5 diamonds, right? Over the total number of ways of choosing, yeah, all right. Just a 5-card hand, okay? So the number of ways to get 5 diamonds over the number of ways to actually just get 5 cards, okay? So when you do this, whoopsies. Okay, the number of ways to choose 5 diamonds, I'm going to put that in red. Well, there are 13 diamonds in a deck, right? 13 diamonds in a deck. We are going to choose 5 of them. And then the number of ways to choose just any 5 cards, well, we have 52 total cards in a deck, and we're going to choose 5 of them. So when we do this and we get those two numbers, I'm going to get those two numbers just because I'm going to write an equal sign right there. Just make that a little bigger. There we go. Equals 1,287. There are 1,287 ways to get 5 diamonds out of 13. Over 2,598,960. Yeah, woo! Crazy, crazy, crazy. So that is 0.0005. Didn't they say like the number of different ways to deal or shuffle a deck? I'm sorry, the number of different ways to shuffle a deck of cards. The total number of ways is actually more than the number of atoms on the earth. Something like that. It's some crazy, but it's actually like true. I don't remember exactly what it is, but it's something really crazy like that. All right, so let's stop rambling, Miss P, and just get to the point. I know, guys. I know. I feel your pain. I don't really, because, I don't mind it. So find the probability of being dealt 5 diamonds from a standard deck of playing cards that also includes 2 jokers. In this case, the joker is considered to be a wild card that can be used to represent any card in the deck. Okay? So for this probability, when we do this, instead of the 13 diamonds that we had, we're going to add 2 to that because the jokers could represent a diamond. So there are now 15 conceivable diamonds there. We're still going to choose 5 of them. And now for this, instead of the 52 cards, we actually have 54 cards, and we're still going to choose 5 of them. So when we get this, it will be 3,003 over 3,162,510, which is 0.00095. So that's your probability for that. I don't remember what example 8 is. Let's go find out. A food manufacturer. Okay. A food manufacturer is analyzing a sample of 400 corn kernels for the presence of a toxin. In this Give me 1 second. Sorry about the pause, guys. I wanted to go double check. I don't think this actual example is in your homework. So I don't think you're actually going to be responsible for it, but I'm still going to do the video just so you can see it. It's a little bit more complex. It's not terrible or not crazy or anything like that. It's just a little bit more complex. I'm actually going to do the jury one first because it makes a little bit more sense, and then we'll go back to the popcorn one. So when you're looking at this, so example 8B. A jury consists of 5 men and 7 women. 3 jury members are selected at random for an interview. Find the probability that all 3 are men. So you've got a couple things you have to find first. So what you do is, so the probability of choosing no women. Okay. There are 7 women. You are going to choose 0 of them. Okay. And obviously these are combinations, order doesn't matter. And then the probability of choosing 3 men. Okay. There are 5 men, you are going to choose 3 of them. Okay. And then what you end up doing is you kind of have to combine that. It's a little bit weird. So what you're going to do is you are going to take probability. Okay. You're going to take the probability of choosing no women, 7, oops, sorry, that 7 should be a little bit smaller. 7, choose 0, times the probability of choosing 3 men, 5, choose 3. And you're going to put that over, well, what you're doing is you have 12 total people, right? 12 total people, and you are choosing 3 of them. So what ends up happening is you basically, this is 1 times 10 over 220. So the probability that you're going to choose 3 men and no women is 0.045. Okay. The food manufacturer example is the same. It's just a little bit weird because we're talking like kernels and one's toxic and one's not and blah, 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 blah. So kind of thinking the same logic, okay? You have 400 total corn kernels, okay? In the sample, 3 kernels have dangerously high levels of the toxin. And so 3 have high levels of the toxin, 397 do not, right? So 3 are toxic, 397 are non-toxic, okay? So, sorry. So the number of ways that you can choose exactly one kernel that is toxic. So choosing exactly one toxic kernel, right? Well, there are 3 toxic ones. You're going to choose one of them. Then since you're choosing 4 total, right? There's 4 kernels are randomly selected. So now what you need to do is you need to choose 3 of them because 1 plus 3 is 4. So 3 non-toxic kernels, right? And there are 397 total non-toxic kernels, and you want to choose 3 of them, right? And so what you do for your actual probability, again, it's just like the jury problem that I did just below here. You've got the number of ways you can choose a toxic times the number of ways that you can choose 3 non-toxic over the total number of ways that you can choose 4 kernels out of the 400 that are there. And so when you're looking at this, oh my God, those are really big numbers. I don't feel like writing them. So 0.030.